All right, in this set of videos, I'm going to be talking to you about slant asymptotes and then later limits. So we've already seen that if the power of a numerator is greater than the power of the denominator, then we don't have any horizontal asymptotes. If the power of the numerator is exactly one more than the denominator, then what we're going to end up with is an equation that looks like a line. If I do this division, I'm going to have a linear plus some sort of remainder. So that linear becomes my slant asymptote. It's what I look like as x goes towards infinity. If the power of the numerator is 2 or more greater, as a side note, we call that an oblique asymptote. Okay, but let's look at this one where we have 1 greater than the denominator. So my vertical asymptote, I know that's going to be where the denominator is 0. So that's going to be x equals -1. X-intercept, well, if I think about where the numerator is 0, let me factor that out. My x-intercept is going to be at 0 or +1. Of course, if the x-intercept is 0, the y-intercept is also 0. But now let's think about finding our slant asymptote. To do that, I'm going to use division. And I'm going to use synthetic division. 1, -1, 0. Bring down the 1, -1, -2, +2. So my remainder is 2. The other way I can rewrite this expression is x minus 2 plus 2 over x plus 1. So putting all of this together, the equation of my slant asymptote is going to be y equals x minus 2. That's because as x gets really, really big, this quantity gets really close to 0. But it'll still add a little or subtract a little depending on the value of x. So putting all this together, I'm going to plot my intercepts. So I've got 0 and 1. Of course, 0 is both x and y intercept. X equals -1 is a vertical asymptote. And now my slant asymptote is y equals x minus 2. So I'm really thinking about my slant asymptote happening as x is getting bigger and bigger. So in the middle here, I don't really look like that slant asymptote. Instead, so that would go through that point, here, here, and so on. This is what happens as x is getting more positive or more negative. And let's think about the way that that's happening. So I'm going to think about making a sign chart for my important values of x. So I can see that x less than -1 is important, between -1 and 0, between 0 and 1, and when x is greater than 1. All right, so first of all, I'm going to think about a sign chart. To do that, I'm going to think about this form of my equation. So if x is less than -1, I'm going to have negative value here, negative value here, negative here. I'm going to have negative times negative over negative. Altogether, that makes a negative value. If I think about x getting really, really negative, well, it's going to look like that negative value minus 2. If x is really negative, then this component is also negative. So I look like x minus 2. So I'm looking like that, but then I'm subtracting a little with this negative bit. So that tells me that I'm going to be under my asymptote. So I'm really close to it, but just underneath it. So I want to try and be just under it. But now also as I get closer to -1, that means that getting closer to -1, this bit gets closer and closer to 0, but still negative on this side, because I have things like -1.1. Now I'm getting bigger and bigger, more and more and more negative. So as I get closer to that vertical asymptote, I'm going to turn and shoot downwards. Between -1 and 0, well, let's look at that. So between -1 and 0, that's going to be negative. This will also be negative, but now my numerator is going to be positive. So overall, that's going to make a positive value. So I'm going to be up near positive infinity on this side. Between 0 and 1, I'm going to have positive times negative over positive. That's going to make negative. So I'm going to come down somewhere. When x is bigger than 1, I'm going to have positive times positive over positive. So overall positive. Thinking about x being bigger than 1, I'm going to look similar to this line, but I'm going to be adding a bit to it. So I'm going to be above my asymptote. I'm going to look something like this. I'm going to go ahead and graph this in Desmos. It says you can check with your GDC. I'm going to go with Desmos just because it's easier on my computer. So x squared minus x over x plus 1. So we have y equals x squared minus x over x plus 1. And here's my graph. So what I had, oops, looks pretty similar. When we zoom way out, it looks like the line y equals x minus 2. And I can see I'm just under it and just above it.